Okay, so next we will go into the different applications to just further elaborate more on the four different applications that I described earlier. So the first one is of course on the microbial whole genome sequencing. So I think currently most of the whole genome sequencing for microbes are still being performed on the short read sequences, right, to actually produce a draft genome. So usually these draft genomes will actually have a few disadvantage. For example, there are poor resolutions of regions that are in terms of like structural variations or like mobile elements such as plasmids, and they might have genes that are fragmented and the genes cluster are not unassembled because of the short read sequences itself, right? And then on the short read sequencing as well, there are no information of the RM motifs as well. So on so all these different disadvantages will actually give you consequences. For example, if you're not sequencing through all these different regions and elements, right, you cannot actually characterize, for example, traits such as antibiotic resistance or the transmission chains itself. And if let's say the genes are not sequenced through properly and it's fragmented, you might inhibit discovery. You might not be able to identify that gene itself, and you will overlook all these drivers of these key traits. And on the RM motifs as well, you will miss the contribution of this DNA modification, uh the this impact of DNA modification on pathogenesis, virulence, transmission efficiency itself. Yeah, so by using hi-fi sequencing itself, because of the hi-fi long read itself, and it's highly accurate also, we are able to actually sequence through all this difficult to sequence regions, repetitive regions, as well as genes that are, because we are 15 kb, right? So we will usually sequence through the genes itself, and like what I mentioned, like the epigenetic side as well, we are able to actually look at the RM motifs also. And with PacBio Hi-Fi microbial whole genome sequencing, you actually do not need short read polishing. Yeah, so this is a very busy slide, but I just want to summarize to you to tell you that on PacBio itself, we do have an end-to-end workflow for microbial whole genome sequencing. So from the we have our nanobind extraction kit that can actually help you to extract high molecular weight DNA. And then we work together with our compatible partners for shearing, uh, for example, things like plate-based high throughput shearing, Hamilton pipette shearing. And as I mentioned earlier, we have our hi-fi plex prep kit, that we can actually multiplex up to 384 samples. And depending on your throughput, this particular kit can be actually automated on the uh, liquid automation platform as well. And then we can actually run, after we prepare the library, we can run the samples on, either the SQL 2E or our Revio platform. And then our smart link, which I think Ting will explain further more later on, that we have a pipeline to actually help to, perform uh, microbial genome analysis. Okay, so by doing that, we are able to identify all these strain characteristics, the MR genes, as well as the mobile vectors mediating spread. Yeah. So just to show you all an example of comparison between short read as well as compared to using PacBio hi-fi sequencing to perform a whole genome sequencing. So this particular case studies was from one of our customers, and they are actually looking into some of the antibiotic resistance bacteria from patient samples. So they use our PacBio sequence, long read sequencing, to actually perform whole genome sequencing, and you can see that on PacBio long read, we are able to actually sequence through a closed genome, a circular closed genome, as well as the plasmid uh, at the site. Whereas for the short read sequencing, you can see their contig assembly graph is very complicated because of the nature of the short read, right? So it has more challenges to actually combine all these different contigs together to form the genome. Whereas for a long read sequencing, we are sequencing through the entire genome itself. So that's why you don't it's much more easy to have the contig assembly graph is much more easier to actually look at. So with this particular contact this particular genome that looks like this, it will also impact your downstream analysis as well if you're looking into, plotting things like phylogenetic trees. And another example is another paper from one of our customers doing uh, sequencing through the MTB or Mycobacterium tuberculosis complex genomes. And they actually, saw that, with just 16x, it was sufficient to actually obtain a closed genome. And the accuracy of hi-fi reads allow them to actually forego many of the complexity of the methods from previous approaches. So, noisy long, if let's say you're using another long read, which is a bit noisy, you will require to, sorry, excuse me, I'm back. Okay. So for things like, because of our accuracy of our hi-fi reads, right, we can actually, forego many of the complex methods that were used for previous approaches. For example, you have to use hybrid approach to combine long read as well as short read together to do assembly. But because of our hi-fi reads are so or are already accurate, right? So we don't actually need to use the hybrid method. And in this particular paper itself, you can see that they are able to actually identify duplications that happened in the MTB genome itself, and the duplication is like 7.2 base pairs long. So you actually have to sequence double of this, which is around like 15 kb, to be able to identify these duplications. So I don't think short read will be able to identify this particular duplication itself. Yeah, and also PacBio sequencing is also being used as part of the surveillance pipeline in the US as well. So in one of the hospitals in the Boston area, they actually use our hi-fi sequencing to be like a second line. So they actually if there's any novel strain of this particular carbapenem resistance enterobacteria, they will actually use our PacBio sequencing to sequence through the novel strain to identify, the strain characteristics, AMR genes, as well as, any of the mobile vectors mediating spread.